Okay, so if they give you, let's look at it again. You got the exponential graph, you got the asymptote 1 to 2. They ask you, if this is the equation, a b to the power x plus b plus q, they ask you to determine b, p, and q. B, p, and q is what you must determine if a is equal to q. Okay, so we know a is equal to q, and it's easy to find q because it's the asymptote, 1 to 2. So we know the constant value is always your asymptote. And they said a must be equal to q. So we can start by saying hx will be 2 b to the power x plus b plus 2. A equal to q. Q is 2, so a is 2. So now we actually just have to solve b and p because we got q. And therefore we got a. So now we can say let's put 2 and 8 or 3 and 4 into the equation. Okay, any one of those two. Okay, so let's start with 2 and 8. 8 equal to 2b to the power x plus b plus 2. Take the 2 over, so 6 is equal to 2b to the power x plus p. Okay, so we substituted 8. No, sorry, we're going to put, we know now that it's 2 for x, so we put 2 in there, and here also we put in 2. Okay, right. So we substituted 8 and 2, x and y, took the 2 over, 6 equal to 2. And now v and p, you can't solve it. What you can do is you can divide both sides by 2, but then it's still not enough to actually solve it. So you just wait with it there. So okay, let's look at the other coordinate, 3 and 4. What happens when I put that in? If I say 4 is equal to 2b to the power 2 plus b plus 2. So I substitute 4 and 3. Substitute 4 and 3. Okay. And I take the 2 over. I get 2 is equal to 2b to the power 3 plus b. Right. Okay. Take it over. 4 minus 2 is 2. Now you can divide both sides by 2. And you can say therefore 1 is equal to b to the power 3 plus p. Now that's something important. Think about that. Think about that. 1 is equal to b to the power 3 plus p. Why is that important? What can we do with that bit of information? Because this one we got stuck here. 6 is equal to 2b to the power 2 plus p. There's nothing you can do after that. Okay? You can't solve it. But now, when you tried 4 and 3, take it over, you get 2, divide by 2, you get 1 is equal to b to the power 3 plus b. You can actually solve it. Why? Because we know from exponents that anything to the power 0 is 1. Anything to the power 0 is 1. Remember the rule, the definition, that anything to the power 0 gives you 1. So if the answer is 1, it means this exponent must be 0. Does it make sense? That's the only way. It has to be 0 because it's 1. The answer is 1. So b to the power 0 is equal to 1, which means 3 plus p must be 0, which means p must be negative 3. So you can say then, therefore, after you said that, you can say, therefore, p is equal to negative 3. It has to be negative 3. That's the only way. So that is this is quite a random kind of thing that you must just remember. When you get stuck with one of the things you tried, go to the other coordinate you have. If you get to 1 equal to this, then you know what to do. P must be equal to negative 3. Okay. Now we can put negative 3 in here. Now we can go back to this one. We can substitute it. And then for this one, we can say, therefore, 6 is equal to 2b to the power 2 minus 3. Okay, we can take the negative 3 and put it in the place of p now. 2 plus minus 3 means 2 minus 3. Yeah, plus 3 plus p. But what is p? P is negative 3. So it's 3 plus negative 3. So it means it's 3 minus. Sorry, there. 2 plus negative 3. So it's 2 minus 3. So if you divide both sides by 2 now, they cancel out. So therefore 3 is equal to b to the power negative 1. So that means actually 1 over b is equal to 3. So therefore b will be 1 over 3. B will be equal to 1 over 3. So there we solve it. We got b 1 over 3, we got p negative 3, and we got q equal to 2. You can write it down if you want to, and we solved that. So we solved all the variables. Okay.